Hello everyone, welcome back to Jom Studyla YouTube channel. Let's continue with our lesson for IGCSE Chemistry, Chapter 8, Acids, Bases, and Oxides. Before further ado, don't forget to subscribe to this channel, yeah? Let's look into our course, our study outline for this topic. The topic comprises of acid, bases, salt, chemical reaction of acid, proton transfer in acid and bases, acid and base concentration, molarity, strong and weak acid and bases, acidic and basic oxide. Acids. An acid is a compound which produces hydrogen ion H positive in the form of aqueous when dissolved in water. All acid dissolve in water to form hydrogen ion. The formula equation is H2SO4 to form 2H positive plus SO4 to negative, and HCl to form H positive plus Cl negative. And thirdly, HNO3 to form H positive plus NO3 negative. Hydrogen ion is just a proton, does not exist by itself. It reacts with water to form hydrozonium ion. Example, H3O negative. H positive plus H2O to form H3O negative. An acid can also be defined as a compound which produces H3O negative when dissolved in water. But hydrogen is not necessarily an acid because an acid needs to have hydrogen ions, H negative, and not hydrogen atom, H. Water needed for an acid to form ions. Therefore, dry acid without water will not have any hydrogen ions if it don't have any acidic properties. And there are two types of acid. One is a mineral acid, the other one is organic acid. What is a mineral acid? Mineral acid does not have any carbon atom. On the other hand, organic acid is an acid which is contain carbon atom. Organic acid, sample of the organic acid is CH2COOH, ethanoic acid, HCOOH, ethanoic acid, and H2C2O4, ethamidoic acid. An example of inorganic acid is as listed below. H2SO4, sulfuric acid, HCl, hydrochloric acid, and HNO3, nitric acid. Acid has sour taste and are corrosive. Acid neutralizes a base to form a salt and water. You can see the below of the chemical equation like 2HCl plus COO to form CaCl and plus H2O, which is 2HCl is an acid plus COO is a base to form salt is a CaCl in the form of aqueous and H2O in the form of liquid is a water. Acid has pH value below 7 and acid have atom which can be replaced by a metal or ammonium ion. Example, NH4 positive. Bases. What is a basis? A base is a compound which neutralizes acid to form salt and water. Let's look into this equation below. 2NaOH is a base plus H2SO4 is an acid. To form Na2SO4 in the form of a salt plus 2H2O in the form of liquid is a water. Most of bases are the oxides and hydroxide of metal. Example, sodium hydroxide, NaOH, and copper 2 oxide, CuO are bases. Not all bases are soluble. Soluble bases alkaline. Example, sodium hydroxide, NaOH. potassium hydroxide KOH, calcium hydroxide CaOH2, ammonia NH3. An example of insoluble base is copper 2 oxide CuO, magnesium oxide MgO, iron 2 oxide FeO, aluminium oxide Al2O3, and most metal hydroxide are not soluble in water. Therefore, they do not form alkaline. Carbonate are not bases. They react with acid to give salt and water. Their reactions also produce carbon dioxide. A base which is soluble in water is called an alkaline. All alkaline are bases, but not all bases are alkaline. A solution of hydroxide ion is produced when alkaline dissolves in water. Alkaline turn them red, litmus blue. Alkaline have pH value above 7. Alkaline dissociate hydroxide ion. So these are the sample of alkaline. NaOH to form OH negative, COOH2 to form 2OH negative, KOH to form OH negative. Let's look into salt, an example of salt. When acid react with metal, a metal oxide, a metal hydroxide, or metal carbonate, a salt is formed. Salt is actually a compound formed when the hydrogen in an acid is replaced by a metal or ammonium ion. Chloride are salt formed from hydrochloric acid. Example, sodium chloride, HCl plus NaOH, which is hydrochloric acid plus sodium hydroxide to form NaCl, which is sodium chloride, plus H2O is a water. Sulfate are salt formed from sulfuric acid. Example, potassium sulfate. Sulfuric acid is H2SO4 plus potassium hydroxide is 2KOH to form potassium sulfate K2SO4 plus 2H2O is a water. Nitrates are salt formed from nitric acid. Example, lithium nitrate. We have nitric acid, which is HNO3 plus LiOH, lithium hydroxide, to form lithium nitrate, LiNO3 plus H2O is a water. Chemical reactions of acid. When chemical reactions with metal, acid react with metal to form salt and hydrogen. You can see from this equation, metal plus acid to form metal salt plus hydrogen. Example given here is zinc plus sulfuric acid, H2SO4, to form zinc sulfate, ZnSO4 plus hydrogen, H2. And when the chemical reactions with metal oxide, acid react with metal oxide to form salt and water. You can see example given here is a magnesium oxide, which is metal oxide, plus acid. Acid given here is hydrochloric acid, 2HCl. To form metal salt is a MgCl2, is a magnesium chloride, plus H2O is a water. And when the chemical reactions with metal hydroxide and aqueous ammonia, and given here is a sodium hydroxide, which is metal hydroxide plus acid. Acid is HNO3 and metal hydroxide is NaOH to form metal salt, which is NaNO3 plus water H2O. So, a solution of aqua ammonia contain hydroxide ion. Ammonia react to form salt. So, example chemical reaction given here is ammonia 2NH3 plus sulfuric acid H2SO4 to form ammonium sulfate NH4 close bracket 2SO4. And let's look into the chemical reaction with carbonate. Acid react with carbonate to form salt, water, and carbon dioxide. So we have example here is metal carbonate, which is calcium carbonate, CaCO2, plus acid, hydrochloric acid, 2HCl, to form salt as CaCl2 is a calcium chloride, plus H2O is water, and carbon dioxide is plus CO2. And when chemical reactions bases with acid, what will happen? Metal oxide and hydroxide react with acid to form salt and water. So example given here 2, which is calcium oxide, reactions with 2HCl with hydrochloric acid to form calcium chloride, CaCl2, plus water, H2O. And the second example about reaction bases with acid is potassium hydroxide, KOH, plus with nitric acid, HNO3, to form potassium nitrite, KNO3, plus H2O water. And finally, we have reaction alkaline with ammonium salt. Ammonium salt decompose when warm with alkalis. So a salt, water, and ammonia are produced. So example given here is when chemical reactions alkaline with ammonia, ammonium chloride, NH4Cl, and reactions with sodium hydroxide, which is NaOH, to form sodium chloride, NaCl plus water, H2O, plus ammonia, NH3. Let's look into the proton transfer in acid and bases. When hydrogen chloride dissolves in water, it ionizes, which means that split up into ions, and during at this point of time, hydrogen ions are formed. So we can see hydrogen chloride plus water to form proton and chloride ion. But on the other hand, when alkaline dissolve in water, it ionizes and form hydroxide ion, OH negative. So we can define acid and bases in terms of the transfer of hydrogen ion. When discussing acid and bases, we usually use the term proton instead of hydrogen ion. Terminology: acid is a proton donor, means that give. Base is actually a proton acceptor, means accept. An acid give means that donate one or more proton to a base. And a base take or accept one or more proton from an acid. So hydrochloric acid is an acid because it transfers a proton to a base. You can see from this equation, acid H positive transfer proton to a base. So in this scenario, base is OH negative to form H2O. H2O is a water. So second example is where a base accept one or more proton from the acid. So you can see proton transfer is from acid to proton. In other words, that base accept one or more proton from the acid. You can see NH3 ammonia plus acid H positive to form NH4 positive. So simplify the equation for proton transfer by ignoring water. You can see HCl to form means that proton transfer to H positive plus Cl negative. Means that the combination of H positive plus Cl negative means that the proton transfer from acid H positive to Cl negative to form HCl. So the ionic equation for the reaction of any acid with any alkaline is from acid H positive plus OH from alkaline to form H2O. Acid and base concentration. A concentrated solution of an acid or base contains more particles of acid or base per decimeter cube than a dilute solution. The lower the pH, the greater is the concentration of H positive ion, means that is equivalent to acid. That means the solution is acidic. The higher the pH, the greater is the concentration of OH negative ion, so is equivalent to base. How to measure the concentration, we will study later. So let's look into what does it mean by concentration. The concentration is the amount of any solute in a unit volume or solution give concentration. The concentration of solution can be expressed in gram per decimeter cube. That means you can see gram G dm negative 3 or mole per decimeter cube. That means mole dm negative 3. So this unit is called the molarity of the solution. How to get, or the formula for concentration means that gram per decimeter, mass of the dissolved solute in gram divided by volume of the solution in decimeter cube. Concentration in unit grams per decimeter cube means that the number of grams of a substance in 1 liter of solution. Okay, let's look into the molarity. The molarity of a solution is the number of mole of solute present in 1 decimeter cube of a solution. So the formula for molarity is number of mole of solute divided by volume of solution, which means that in a form of decimeter cube. So if you want to get the number of moles, means that molarity times volume of solution. So molarity means that mole per decimeter cube and times by volume of solution in decimeter cube. So if you want to find the number of moles, means that molarity times volume of solution, moles divided by 1000. So example given here, a mole of substance is equivalent to its molecular mass. This figure you can get in the periodic table. Example, it gives that 1 mole of NaCl. Na, if you refer to the periodic table, is having a mole of substance 23 gram, whereas Cl having a mole of substance is equivalent to 35.5 gram. So the total of 1 mole of NaCl is equivalent to 58.5 gram. So you can see here, 1 mole solution of NaCl equals to 1 m, 1 molar mass of NaCl, equivalent to 58.5 gram if dissolved in water. So then water is added until the volume of the solution is exactly 1 decimeter cube. So if we want to get the value of 2 molar solution NaCl, that means 2n will contain 2 mole of NaCl. What you have to do is 2 times 58.5 gram in 1 decimeter cube of solution. Alright, so you get the value of how many? 2 times 58.5 is the answer. 0.5 molar solution, it means that 0.5 m solution of NaCl will contain 0.5 mole of NaCl, means that 0.5 times 58.5 gram in 1 decimeter cube of solution. This is, you have to memorize the formula to calculate the concentration as well as molarity. Let's look into the strong and weak acid and bases. What does it mean by strong acid? Strong acid ionize completely, deassociate completely in solution. Example given here is hydrochloric, sulfuric, and nitric acid are the strong acid. ACl, which is actually to form H plus Cl negative. So you already learned about the proton transfer and also proton donate, accept and donate. So strong bases ionize completely in solution. Group 1 hydroxide are strong bases. Weak acid are only partially ionized, means partly deassociated in solution. There are many more molecules of unionized acid present than there are ions. There is an equilibrium between molecules of unionized acid and their ions. Example given here is ethanoic acid. Ethanoids, Ca3COOH, are weak acid. And weak bases are only partially ionized, means that partly deassociated in solution. There are many more molecules of unionized base present than there are ions. There is an equilibrium between molecules of unionized base and their ions. Aqueous ammonia is a weak base. We can distinguish strong acid from weak acid by comparing solution of equal concentration. At equal concentration, and strong acid have a lower pH than weak acid. Strong acid react faster with metal, metal carbonates, metal oxide at same temperature. But strong acid also conduct electricity better than weak acid. So we can also distinguish strong bases from weak bases by comparing solution of equal concentration. At equal concentration, strong bases have a higher pH than weak bases, and strong bases also conduct electricity better than weak bases. Okay, finally, we have a terminology, means that if you want to more understand about what does it mean by the strong acid or base, means that an acid or base which ionize completely in solution. But weak acid or base means that an acid or base which ionize only partially in solution. And we have a amphoteric and neutral oxide. Amphoteric oxide react with acid as well as with bases. A salt and water are formed, example aluminium oxide and zinc oxide. The hydroxide of aluminium and zinc behave in similar way. Aluminate and zincates are soluble in aqueous alkaline solution. Terminologies for neutral oxide, which means that an oxide that does not react with acid and base. And amphoteric oxide means that an oxide that reacts with both acid and bases to form salt and water. Okay, with that being said, I would like to wish you all the best in your study. Hope you are clear with the presentations of this subject matter. And you can get the details or customized notes by clicking Jom Studyla Instagram. And last but not least, please press the thumbs up like button and subscribe to Jom Studyla YouTube channel and follow me at Jom Studyla Instagram. Thank you very much.